Good morning everyone. I am Tanushree from Civil Engineering branch. So in the last class we discussed about the bending moment calculation of a simply supported beam having 2 point loads and one uniformly distributed load. So we calculated up to point E, and today we will calculate the bending moment at point F, and how to draw the bending moment diagram we will see. So at point F, I told you we need to consider the right side of the section because the less number of loading condition. So the bending moment at point F you can see at the right side of this point. So here one load condition is there, which is a reaction at point B, that is RB. And the distance from this reaction to the point F is 1 meter. So we can say the moment or the bending moment of the point F is equal to load into distance, that is RB into distance, which is the RB value is 12. So 12 into distance is 1 meter. So 12 into 1, that is 12 kilonewton meter, which is the value of bending moment at point F. And now the new point, which is the point G. So to calculate the bending moment at point G, we can take the help of right side or left side of the section, because the G point is arrived or rising at the point of midspan of the total beam. So now we considering the right side of the section. Here also 3 loads are there because one is reaction, second one is point load, and third one is UDL. And if you will look at the left side of the section, here also 1 point load, another point load, and third is your UDL. So we can consider any one side of the point G. So here we will consider the left side of the section. So if we consider the left side, then here one reaction is there, which is the reaction about A, which is RA. 1 point load is there, which is 4 kilonewton, and one UDL is there, which is 2 kilonewton per meter. So first of all, we will calculate for the moment at point A. So first of all, the moment calculation for this point G, here RA value is there, which is 8 kilonewton, and the distance from the point A to the G is 5 meter as we calculated before. So we can say the moment calculation will be RA into 5, that is load into distance. And this reaction gives a sagging moment towards the point G. So the sign of this moment will be positive in nature. So 8 into 5 is positive. Then comes to the point here, that is 4 kilonewton, which is a point load. So this point is denoted as C. So the load is 4 kilonewton and the distance from the C to the G is 3 meter. As we know, the DG value is 2 meter and the CD value is 1 meter as given in the question. So the total distance from the C to G will be 3 meter. Hence, the moment calculation for this point load will be 4 into 3. And it will give a moment of hogging moment towards the point C. that is at point here. So 4 into 3, here another moment of the section. Again, another loading is there, that is UDL, which is 2 kilonewton per meter. And the distance from this point, that is D to G, will be 2 meter. So we can write for the UDL, the moment will be load into distance by 2. So the load is 2 kilonewton per meter, distance is 2, and distance by 2 is 2 by 2. So here we can write 2 into 2 into 2 by 2. So the sign of this UDL will be negative because it will give a hogging moment towards the point G. Hence, the total moment calculation of the point G will be 24 kilonewton meter. So as I told you that at the point of zero shear force, the maximum bending moment will be occur. So you can see the total bending moment at all the point, the 24 kilonewton 4 or the 24 kilonewton meter will be the highest value of the bending moment. So now we can draw the bending moment diagram according to the each salient point present in the beam. So first of all, at point A and at point B, the bending moment is 0 due to no distance and only loading system. So first of all, we need to draw a reference line for the easy drawing. So here at point A, that is 0, and at point B, that is also 0. After that, at point C, the bending moment is 16 kilonewton. So here we can write a point or give a point here which denote the 60 kilonewton meter. After that, at point D, the bending moment 20 kilonewton meter. So it is above of the C point bending moment. So here is your 20 kilonewton meter. After that, at point E, the value of bending moment is again 20 kilonewton meter. So the E point is here. So here is the point of 20 kilonewton meter. After that, at point F, the bending moment is 12 kilonewton meter. So the E point is here. So it is 20 kilonewton meter. And again, the bending moment at point F is 12 kilonewton meter. So the point F is here. So here is your 12 kilonewton meter. And last, the bending moment at point G is 24 kilonewton meter. So the G point is here. So in this point, 24 kilonewton is there. So you can see, to joining this all the point, we can get the bending moment diagram of this beam. And another thing is there, from the point D to E, the UDL is placed so that the bending moment from D point to E point, it look like a parabolic shape. Because I told you in the previous class, the bending moment will be parabolic in nature in case of UDL and straight in case of point loads. So that the portion on which UDL is acting, that portion will be in parabolic in nature in case of bending moment diagram. So in this way, the shear force and bending moment calculation of beam of simply supported subjected to point load and UDL is over. So today this much. Thank you.